Another day, another experiment. As you can see today, we've switched it up even more. We have our lab coats, but we're not in the garage. We're in the kitchen, and I have more than just one helper today.
Hi, good.
Introduce yourself.
Hi, I'm Evelyn Morgan, his youngest daughter. Hello again.
Hello, I'm Katie, his second youngest daughter.
The middle daughter.
Yeah, the middle.
Hi, I'm Madison, and I'm his oldest daughter.
So old. She is like,
She's 78.
well, it's more like 37. It's more like it's time to get a job. Yeah.
Yeah.
So, today,
how
you guys
old
actually
is
don't
it?
know what we're doing. Katie, you know one thing that we're going to do. We're going to do just a couple fun, quick little experiments.
My numbers.
And just pound through. One of them we'll set up, but we won't finish it today. We'll actually finish it tomorrow. But with the magic of editing, you won't notice that. So, Katie, I wonder if you want to switch places with Katie. Katie, you're going to be on for this first one. Can you tell them the things that you will need for your experiment?
I will need a measuring cup that has 1 cup. I need some vinegar, 1 cup of vinegar, and then a glass and an egg. Nope, not to eat.
Okay. Now, why are we doing this?
For school,
What do you expect to happen is what I mean. Do you know?
No.
Is it just going to see what happens if we put an egg in a cup of vinegar?
Basically.
Basically? Awesome, let's do it. There's your cup. There's your vinegar. I'm not strong. Here, you hold that.
How about let's go noodle arms?
I got it. That goes there now. Okay. I'll pour this so you don't spill, because she's really good at spilling.
She's really good at falling.
Yeah, and there's that. Oh, but I'm going to spill too. 1 cup of vinegar. Oh, it smells so good.
No spilling.
It just looks like water.
And there's that. So it's just a cup of vinegar. That's it. And what are we going to do with that egg?
Next, for the egg, we're going to gently put it in the vinegar.
You're not just going to pull from here.
No.
That's a good idea. And then how long are we going to wait?
24 hours.
24 hours. Give me a prediction. Give me your hypothesis. What do you think will happen to that egg 24 hours from now? After sitting in a bunch of vinegar.
Can I think hypothesis?
Yeah, hold on.
Something will disintegrate on the egg.
Something will disintegrate on the egg.
Yes.
Something will like dissolve away.
Mm-hmm.
What do you think will dissolve?
The eggshell, because it's on the outer layer,
Uh-huh.
so and nothing will be able to get in unless it gets through the outer layer.
Oh, so just the shells, something's going to happen to the shell?
Yeah.
Okay, Evelyn, give me your hypothesis.
I think that some of the pieces on the eggshell are going to break off, and then eventually it will just dissolve.
The whole thing?
Mhm.
The whole egg?
Yeah.
Okay.
But
Madison, are you going to make a claim here?
I'm going to agree with Katie. I think that the eggshell is going to disintegrate because vinegar
Dissolve.
is... Dissolve.
Dissolve is the
Dissolve.
word we would use.
Because vinegar is acidic.
Vinegar is acidic.
what
Like
does
not,
acidic mean?
it means it's a type of an acid. Not like it's going to hurt me. I stick my fingers in it all day, whatever. It's
Don't
just,
look it.
it just smells funny, but it's not going to hurt me. That's why we have lab coats. But, so we have 2 people making the claim
Wait, but if it dissolves the shell, then the yolk is just there, so
so the whole thing will.
yeah.
Okay, so we have 2 claims that just the shell will disintegrate, or will dissolve is actually the proper word to use. And then Evelyn thinks that once the shell dissolves, the whole thing will then continue to dissolve. So, we'll do it just like this. And we'll plop this in here.
Because the egg yolk will be exposed. Whoa.
Boom.
It's so big.
It's got a little couple of bubbles. It's not, it's just got bubbles from the air. Okay, so, and now, like we said though, how long are we going to wait?
24 hours.
24 hours. And with the magic of video editing, boom, whoa! 24 hours went by just like that.
Yeah.
And we magically changed clothes. And my glasses fell off.
Yeah.
And we lost 2 of your sisters. I don't know what happened.
Neither do I.
Oh my gosh. So, let's check on this egg, right? Okay, do you remember what your hypothesis was?
Yes, that just the outer shell would dissolve.
Uh-huh.
And
What is it going to leave?
just not just the yolk, but the other layer that's underneath the shell.
So like the
Wait.
egg white part? Like when you fry an
Yes.
egg, not the yellow part, but the white stuff on the outside? Okay, well, here's our egg in a cup. Looks foamy.
Yeah.
Does it smell good? Nope. Still smells like vinegar. Okay, that means
Here we
you. I totally regret that. I'm gonna get some paper towels.
Okay.
So you know what? Not paper towels. I'm just gonna get a bowl. Should we get a bowl? Plate? Here, let's get a paper plate.
Yeah.
Okay, paper plate. You reach in there and take that egg out of it, not me. That's your job now. See? Okay, put it on your plate. Go ahead and rinse the vinegar off your hands.
Yeah.
Okay, we gotta get a towel real quick. That's good.
I got the foam on my hands.
That's okay. Just dry your hand off real quick. Okay, so let's get rid of that. Big nasty. Okay. Oh, it felt weird. Oh, it doesn't feel right. Go ahead. You do it. Pick it up. What does it feel like?
Oh, it feels slimy.
Slimy? Is that because of the... Okay, well, let's go like this. Let's rinse this off too.
I got more of the vinegar on me.
That's all good. Okay, we'll take this. Try this guy off. Gotta be careful because it's an egg, right?
Yeah.
Yeah. Okay, here's your egg. Now, hold it over the plate just in case something bad happens. What does it feel like now? Because remember, an egg is, it's kind of hard, right? It's got that hard shell on the outside. But what does that feel like now?
It feels squishy.
Squishy.
And it feels like there's a bunch of stuff sticking to it.
Stuff sticking to it? Let's see what we're talking about. So, oh,
Look
yeah.
at my hand.
Pull back just a little bit. All right, like that. Yeah, we got this white stuff on our fingers, and if I rub it, it's almost like it's coming off
The egg.
of the egg, huh?
Yeah.
What do you think this white stuff is?
A little bit of the hard eggshell that's left, but it's still a little bit wet.
Yeah, it almost feels like it's part of the eggshell that dissolved. It just hasn't come off all the way.
Yeah.
You can tell I don't have my glasses on because I keep going like this.
Yeah.
See it, it's so far away. But you're right, Katie. Your hypothesis was correct. You can actually, watch this. Burn, burn, burn. Can't do that with a regular egg, can you?
No.
Burn, burn, burn.
And
Do
it's
you think it bounces?
like-
Like a little bit. Not
Yeah.
like, but just like a little bit. Should we try it?
Mhm.
Here, you try it. It's your egg. That's so cool! Bonk, 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 bonk. Bonk, bonk, bonk. It's like an egg bouncy ball. I want to.
It's like an egg ball.
You picked that up pretty high before you dropped it.
It was an egg ball.
An egg ball? Egg ball! Let's go play baseball with egg balls. I'm not sure that'd be a good sport. Even when I wonder if we drop it like right on the eggy point. Bonk. Whoa! That went so high. Bonk. Yeah! Don't tell your mother. So, lab coats are awesome.
Yeah.
That smells so weird. That's the stuff. You're right though. That's what's left
Yeah.
over the shell
Yeah. And
from where the shell
you can-
dissolved.
If you rub on your fingers, you can like see it come up.
It feels so weird. So I wonder if you left it in vinegar even longer, like if we left it in there again, like would more of it dissolve? I don't know. So it's pretty cool. You want to know what happened?
Yeah.
I won't really tell you what happened. So the outside, that harder layer, is it's made of proteins that the chickens make. The outside, the hard shell, but this inside, what's still there, what's squishy, is a membrane, and that membrane is so water can't get in or out of the shell. It's watertight, And so it doesn't allow the vinegar, remember, because vinegar is
Acid.
exactly,
Acidic.
it is acidic. So the membrane doesn't allow the vinegar to actually penetrate any farther into the egg. That membrane is the really, really protective layering that keeps the baby chickens, when they're in the eggs, safe. Another good time with science stuff, fun stuff. This is one that you guys can do at home. And you totally should, because it feels so weird to squish an egg. What do you think would happen if you squished it too hard?
It'd break.
You think so?
Yeah.
I bet it would too. So Katie decided she wanted to pop the egg. Let's see what it takes. Hold your hand over the sink. Hold it so we can see. Are you gonna like drop it in there?
Whoa, and look.
Yeah, that's more of the shell. That's cool. Okay. Go drop it. Oh yeah! See, that's how the shell's coming off. That's even more of the shell. Look at that. Oh my gosh, I bet if you washed it, the whole shell would come off. Oh, that's so cool.
Whoa,
Here.
and feel it, feel it, feel it.
I know. Get it under the water. Wow, we have more science. More science. Put right on that part. Look at that! Oh my gosh, the whole shell's coming off. This is so cool, you guys. I know you may not care as much as we do, but this is wicked. Oh, now feel it. Oh, and look. If you look inside, here, let me turn on this light. What can you see in there?
The yolk.
That is so amazing!
You can see the yolk before you cook it.
Oh my. Well, I probably wouldn't cook this egg now.
Yeah.
It's been sitting in vinegar. That'd be the weirdest tasting egg. Okay, well, hold on. I want to show them. So this is what it looks like now. Oh, dude. Oh, this is so cool. Just a little bit of water, and it just...
And you can like pinch it and it'll come off.
Well, you just rubbing. I'm just rubbing. What time is it? Oh, we gotta finish. We gotta finish. Okay, so this is what it looks like. Whoa! Oh, that's what it looks like. That's so cool. Okay, you want to drop it from a little higher, see if it breaks now?
Ew.
Go ahead.
That's the yolk.
I know.
Yeah, there it goes. That's dogs. So this is that membrane we were talking about. Here's the yolk. I know. Okay, should we do another experiment?
Yeah.
And you three don't actually know anything about this experiment. So let's do this. Let's, Katie, over there, Evelyn, here, Madison, behind Evelyn. We have 3 different glasses. As you can see, we have 2 wine glasses, and then we just have 1 regular glass. Evelyn,
Yes.
you're the youngest. What glass would you like?
One of the wine glasses.
One of the wine glasses. Katie,
Wine glass.
wine glass. Madison, that means you're on regular glass duty.
Yep.
Now, the thing that we're going to try and do is I want to see if we can decide what the difference between a mixture and a solution is. Evelyn, have you learned about mixtures and solutions yet in school?
I've only learned about mixtures, and that's only when you mix things together. Like, if you mix water with salt, that's only mixing it.
Yeah, you can mix stuff together. Most of our food that we eat, most of the stuff that we drink, besides water, water is not really a mixture, it's something else. But don't point it, you don't want to point it. Most of the food that we eat is a mixture. Katie, grab that thing of Chex Mix over there.
It's
So
bread and salt.
this
It's bread and salt.
is
Bread
a
and
mixture.
Mhm.
No. What I mean is we've mixed some things together, haven't we? We've got, here's some Chex, here's, what's this, pretzel, and here's,
A window pretzel.
you know what these are?
I love those.
Delicious.
A rye chip. I don't know, it's the best thing. So this is just a bunch of different stuff thrown in the same thing, mixed together, makes a mixture. Now,
And we
I will
also
say
add
salt water is actually not
Hmm?
a mixture. Salt water is a what?
Solution.
Salt water is a solution.
What's a solution?
We will find out here in just a little bit what that is. So let's set up this demonstration first. First thing we need in every one of these glasses, half a cup of vegetable oil. There's 1, 2, ooh, And 3. Okay, and then we need some water. And then watch what happens. What do you guys think is going to happen when I pour the water into the oil? Give me a hypothesis, Katie.
That the oil will rise and the water will sit on top of the oil instead of mixing.
Because
Oh.
you can't mix it because all it's gonna do is just sit there.
All right. What happened?
The oil rose to the top.
The oil rose to the top. So what does that mean about water and oil? Which one is more dense?
I think water is more dense.
Water is more dense. That's why it goes to the bottom. Okay, and there's half a cup of water in this one. And there we go.
There's
There's
like
that.
bubbles trapped in
There's
between
that.
the layers.
A little bit of air bubbles.
Stuck in between.
That's so cool. Madison, there's yours. Now earlier you girls picked some colors of food coloring. Normally we would use liquid food coloring. The ones where you just like drop, drop, drop. Boom. We don't have any.
No.
So we'll see if this part works. I don't know. Go ahead and just squeeze a little bit in there. Yeah, Katie, a little bit more. Madison, more. Keep going.
Whoa, it sank to the bottom.
Isn't it? Oh, look at that. That's so cool. Ready for the next part?
Yeah.
Yes.
So explain to me what we've done and what has happened. What did you see? Give me your observations.
So we poured the half a cup of oil in, and then we poured the half a cup of water in, and then the oil is less dense than the water, so it rose to the top and the water sank to the bottom, and then the gel,
Food
the
coloring
food
gel.
coloring gel,
Uh-huh.
sank to the bottom because it's dense.
Is it more dense than water?
I think so.
Well, if it was less dense than water, where would it be? Would it be below the water or above it?
Above the water.
It would be above it. So,
It's more
Katie.
dense.
the food coloring gel, is it more or less dense than water?
It is more.
It is more dense. Hands open. What are these?
Tab thingy, my bobber, heart tab,
Thingamabobbers?
heart tab.
Antacid.
Antacid. It's Alka-Seltzer.
Alka-Seltzer.
Alka-Seltzer. Hey, so these little tabs, these are the same things. Just hold on to them. These are the same things that you guys got in the science packets to do the 3, 2, 1 pop when we made the rockets.
Oh, that was really cool.
So, if you went and got your packet, or if you go and get your packet this week from Mrs. Baldwin coming up, you will also get more antacids because you're going to use it to do this experiment. So we've got 2 glasses, 3 different colors. I know what's going to happen. And the reason we have this glass is because I want to see, hold on baby, dump that extra stuff in here. We don't want that. Just hold that. I want to see if there's going to be a different reaction between the shape of the wine goblet and just a regular glass. On the count of 3, you're just going to reach in and just gently set it in. Don't drop it. Don't make a big splash or anything like that.
Just
Let's-
on the top of the water.
Yeah, just reach in and set it in. And then you have to remember to make your observations as it goes, okay? So, ready? 1, 2, 3.
So it's bubbling because it went straight down to the water.
Yeah, because it does not float, so it's nice and dense. Ooh.
Whoa, look at the oil is making like waves because of all the bubbles, but
It looks like
the food coloring.
So what's
isn't
the
doing
difference
anything.
between the, yeah, because the food coloring can't get above the
Water.
antacid.
Oh
So
my-
what's the difference between the water and the goblet? You guys see the big difference?
Because
I'm sorry, not the water and goblet. This glass and this glass. Did you see the main difference?
I don't see much of a difference.
Oh, okay. Well, let's see if we can do this.
Again.
To get, yeah,
But it's got this big stuff in the middle.
big blorb in the middle. That's so cool.
I noticed the
Roll to
antacid
the top.
tabs floated to the top at the end.
At the end, they
Because-
did. Once they finally became nice and light. So I'm going to drop one in here again, and we'll see. It should work again. Watch where all the bubbles are located. They're very kind of centralized, aren't they?
Yeah.
Good.
Yeah.
Just pot spooling just in the center.
Yeah,
And
it
now
is.
it went to the sides.
Kinda.
But it was like big bubbles.
Yeah.
Like the-
But then when we did it in this cup, it was just kind of all
Whatever.
over the place, wasn't
Yeah.
it?
Whoa, look
Yeah.
at it now.
So what do you think? Sit up. What do you think was happening?
Maybe the shape of this is forcing the bubbles to go into the center.
Almost like a volcano.
Yeah, it's like forcing it to go to the
I
center.
think that since
Good job. That's exactly what was happening. So this was a fun, just cool little demonstration experiment that you can do. So question, oil and water, are those a mixture or a solution?
it's a solution.
Mixture.
Katie is right. It is a mixture. A mixture is something, here, watch out, let me show you. A mixture is something that you can
Mixed together.
mix together, but you can see that it's still its own thing. So these were mixed together in one glass. A solution, though, and I'm going to stir up Madison's real quick.
Whoa!
A solution would be something that once it's been combined, you can no longer separate them. And this isn't going to work really well because of the type of food coloring we use. But you can see
It's so bubbly.
some
Water is green.
of the water is green, and then you've got the green water. Is that a mixture or a solution?
Solution.
It's a solution because I can't separate the food coloring that's already been dissolved into the water. I can't separate that back out again. But when you look at the oil and the water, is that a mixture or a solution?
Mixture.
That's a mixture because I could easily separate those out. Now, if you guys do this at home, as like I said, it happens sometimes in experiments. This food coloring, the paste stuff, it did not work. Didn't work at all. Not the way that it was supposed to. If you use just the liquid stuff, it's actually really cool because in the bubbles that come up, the big bloop of bubbles that come up, they're actually the same color as the food coloring that was used.
So it looks like a lava lamp.
It does. It looks like a lava lamp, or if you use red, it looks like a little mini volcano. It's super cool. Awesome.
It's cool.
Yeah.
Can we mix this up?
Can we mix that up?
Can
Yeah.
I mix mine up?
Sure, we can tear this stuff up. So, do this one at home. Mrs. Baldwin and I are going to send home some more antacid tabs for you. If you have food coloring, awesome. Use the liquid food coloring, and you'll be able to see it. It's pretty cool. If you can, should they use a wine glass or a regular glass? What do you think?
Wine.
Why? Was it
Regular.
cooler? What do you think looked cooler?
I
They all
don't
looked
know.
cool.
They did all look cool. I thought the wine glass looked a little more fantastic. Oh, there we go, Katie. That's a really good shot. Look at that.
Look
Looks
at
like
mine.
Solution, mixture.
I think the
You
wine
can
glass.
definitely see this is the solution, and then the whole thing is the actual mixture. Well, this is
That was so cool.
a portion of the Morgan family.
Still not all of us.
Not all of us. There's too
Okay.
many of us to even fit in this kitchen together. So, signing off. Evelyn,
Yes.
help me out. Until I see you again, stay safe, stay healthy, stay home.